Hey guys and gals, today we'll be implementing an AI for a simple stealth game in Godot. Uh, I'll try to keep all the most of the concepts themselves pretty engine non-specific, but here goes. So the first thing that I want to do is actually give you a quick summary of what we have in the project so far, in the demo so far. Press F5. While let's see, we have a player. He can move around, but he doesn't actually walk, even though animations or are done. They're just not stitched together yet. Um, got the vision for our enemies. You can see the player. Press K. Wow. Now if you go debug mode and press K, prints out true for this guy's vision side. Whatever. Um, it can also the world also has an emergency state. You can get shot. You can lose health. Yada yada yada. Nothing really impressive happens yet because we'll be doing that right now. So yeah. Also, we got pathfinding. We can even move along pathfinding, just great. And there's also an emergency state for the level, and you can get shot, and you can use your health. Wow. So that's that. All good. Great. To actually implement our AI, we're going to employ something called a state machine. So a state machine, I'm sure most of you already know. Well, yeah, I'm sure most of you already know. Is basically just an object that keeps track of a subject and has keep track of the object's state. And while the subject is in a specific state, um, state machine just tells the object to do something. And when the subject moves between states, the state machine will tell them to do something else. Uh, Simple enough, right? So to do this, we're just gonna create a new script, which is basically in this language is equivalent to defining a new class. It's gonna call state machine. It's just gonna inherit. It's gonna inherit from the most generic. It's kind of. It's gonna. It should probably be lightweight, so it's gonna generic. Should inherit from the most generic object can, which in this case would be the language would be the node. And it's going to have. It's obviously going to need to primarily remember what state we're in. So when we say we're going to declare a var called state, and we're going to declare another variable called states, which is all the states that the subject can take. In some cases, this might be profitable to know to remember the previous state that that you're in, that the subject was in, and obviously we're going to need to remember the subject itself. In this language, we just do that by going get parent, which basically just references whatever this node that has this script, i.e. whatever the state machine is attached to. So, yep, for the functions, and this is the good part. So every frame, the function state logic is going to be called, and it contains, well, the logic, i.e. what happens every frame in each state. I don't know how many times I can say the same sentence. We also have a transition function. We also have the function transition, which simply gets what state we will change into this frame. Yep. So basically, checks the current state, or checks a state, and returns given the current conditions of the world or whatever, what state the subject needs to change into, and we need a function called enter state, which is basically our initialization function. So whenever so sometimes, depending on what state you are, depending on your state machine, so I should say, you might want to initialize certain variables a certain way whenever you enter a state. and also and also you might want to deinitialize or clean up some variables when you leave a state. So we're just going to function for that there too. They're going to be empty for now because state machine is just a class. The implementation for each of them is going to be specific, so we'll just inherit from state machine. Speaking of inheritance, don't forget to declare. Don't forget to declare state machine is something you can actually inherit from. That's probably pretty important. Okay, so we're gonna stitch the enter state and exit state functions together with the set state state function, which basically does enter state, new state, okay, and exits. And then actually changes the state to the new state. But not before recording the state we just moved away from. Wow. In some cases, again, you might want to keep the previous state, record the previous state as a stack if you want to record all the states that your subject used to be. But for this case, that will be necessary. I don't even know if previous will be necessary, but whatever. And we're going to finish it off by going physics process delta, which is an so this is basically just an in-engine function that automatically gets called every frame. So we're just telling the engine, hey, every frame, I want you to do the state logic. I want you to do the state logic. I want you to call this your frame and then go and then check if we need to change into a new state. Given our current state. Oops. And if we do, set state. And if we do, set new state. Wow, simple as that. Easy as 1, 2. This is 3. In fact, we can break style a little bit by doing that. Okay, no, we won't. Okay. Okay, so before we actually implement the AI, we're going to use our state machine to finish up the character scene, to finish up animations. It's a character scene. It's what all the AI and the player inherit from. Okay, so in order to actually use our state machine, what we want to do is we want to create a child to the node, to the head of the character scene. The child will be a state machine, boom, but we're going to extend its script to basically say, hey, this isn't a state machine proper, but simply an object that inherits from state machine. I'm going to call this new type of object a char state. Wow. We're also going to call the child main state, so it's a bit confusing. Okay, so immediately what we're going to want to do is we're going to want to initialize this new object by adding the states idle, I'm walking here, and dead, and then we're going to, for the state logic, actually, for the sake of brevity, let's just copy all of this. For the sake of brevity, for state logic, we're going to use a switch statement. Actually, no. It's only going to be one case. So if state equals walking, subject, wrong equal statement, subject dot walk, subject dot velocity, and for transition, because there's going to be more than one case, we're going to use a match statement. For now, just use ifs. If state equals idle, if state, if subject dot velocity is not equal to the 0 vector, return I'm walking here. If subject dot health is less than or equal to 0. So if the character's health is less than or equal to 0, then tell him to go die. Tell him to go die. And if alternatively, if state equals state star and the movie star equal to 0 vector, change to idle. And for the state initialization, okay, because we're gonna be another if statement's fine for now. So if state is idle, not even state, it's new state. Then we go subject dot, I think it was called idle animation, subject facing. Yep, so tell it to change its animation. Tell the character to change its animation to the direction it's facing. And if state equals dead, dead, and subject basically just tells the entire world that, hey, this character's friggin' dead, lol. Yeah, and that's it. Oh, also, there's the subject also has a variable called isDead. And I think for now that should be it. Okay, so don't do state equals idle here. You're actually going to remember to set state to idle, so you can properly initialize. Sorta. I mean, yeah, you can. He's only four sprites. Okay. Now that the actual AI is the first AI we're gonna implement is this guy, the sentinel. We'll just make him look around, and if he sees the player, shoot him. So to do that, let's just double click his scene in the file system. Before we actually add an AI, damn. Let's add a on the state machine node to the character scene. Call it AI. For most characters, it'll just be the placeholder AI. For Sentinel, we're gonna extend that to some file called Sentinel. Wow. So for this, what we're gonna do is we're gonna need a variable called var time in state equals 0. As you probably guessed, state every frame we're going to want to increase time and state by the number of by how much time's passed, and when we enter a new state, while we okay, so the three states that we're going to want to add are idle, looking around, and shooting player. One more thing that we're actually going to do in the state logic for that though is, for convenience, let's add let's change the dialogue of our good old sentinel dot set text okay. Actually, no. There totally just exists a function called set dialogue to the state that we're in. Wowee. Actually, even better. Just do that whenever we enter a state, so we don't do it once. Okay. So for state logics, we use a match statement because it looks a little bit better than if statements. If no, idle, and nothing will happen. Around. We're gonna do some weird math, and we're gonna go 2 rotate equals 2. No, not 2. Let's make it 0.5. Yeah, 0.5 times pi times cos plus 2 times pi times time and state. And go subject dot facing equals subject dot facing dot rotated. Rotate. So basically, this math does. So basically, this is the derivative of a sine function with amplitude. Amplitude quarter circle. So what it does is it just makes the makes the sentinel look around a quarter of a circle in radius. Actually, no. If it was making a quarter circle, we want to make it an eighth of a circle. So, okay, you want to make the amplitude an eighth of a circle. So the sentinel will just look around a quarter of a circle, and while it's in the looking around state, over the course of a second, that is. Cool. So, and for the final state, shooting player, if not shoot. Okay. dot shoot, and if subject dot player in range subject dot player in range subject dot facing equals subject dot face player. That's a function that exists totally 100%. But the looking around rotating, nope, that's just math. Face player totally exists, totally. So the face player in range, face player. Cool. Actually, just make a face. Just make the boy face player anyway. Doesn't have to be in range. So for transition, let's copy everything. Whoa, whoa, ho, ho, ho. Whoa, Nelly. So for idle, if subject can see player, can't see player, turn shooting player. Something similar happens here as well. Oops. Additionally, no, if time in state is greater than 1, greater than or equal to 1, turn idle. Over here, let's change the bit sporadic, but no, we'll do it later. Do the variant. So transition for this shooting function. If subject dot player in range. If player isn't in range, stop shooting. Return cool. There's one thing we need to do. So if there's one more thing we need to do, and it's if state equals idle, reset subject reset face. You know what? I'm too lazy. No, we'll implement it here. So enter state. So we want onReady var initial facing equals subject dot facing if state equals idle subject dot face. So just reset its facing every time when we go to idle. Okay. Okay. Debugged a little bit of my implementation and of the non-AI stuff, and should be good to go. Yep. As soon as you can't see me, he's gone back. Wow. Oh, looks like it died. So that's the Sentinel. Like, speeding up a little bit, the state machines for the other AI are largely the same. The Marauder will alternate between wandering, where he picks a random spot and moves along the path, moves along the shortest path towards that spot, and looking around. Every 7 seconds, he will return to the original spot that he spawned at. Each instance of a patroller has their own patrol path. When they don't have a normal path that all characters have, they will save uh, the patrol path as that path and just move across that. When they've reached the end of their normal path, they'll just repeat the process while patrolling, and of course they'll look around and shoot the player otherwise. The green one will wander around much like the Marauder, but when the player is in range, he'll charge directly at the player and kill them instantly. What's this? It looks like we're trapped. Looks like there's no way through. In order to get past a situation like that, let's implement a distraction mechanic. So, to do this, we're gonna go to the state machine of the Sentinel, and we're gonna add a connection. So subject dot level dot connect coin dropped self, and a new function we're gonna call. We're gonna go connected, and then we're gonna just add that new function above state logic. Func coin detected position at and basically this is just going to induce a state change. Set state making pickup coin outside. It's going to induce a state change outside of the main loop. And then we're going to have to point to the position in which the coin was dropped at. Actually, for that, we want to check if the coin is in the range for them to notice it. So it's less than, I don't know, just pick a number like 100. Then let's say to pick up coin and set target point at, and then enter state if state equals coin. We tell the subject to request a path. As fast to target position target point. Additionally, we're going to want to create another state after that. Much like the Wanderer, all they're going to do is request a path back to where they started. So, if state we're just gonna do something like and it will be the exact same for returning to position as well. To origin, return to origin. Additionally, finally for the transitions and for return to origin, okay, that should be it. Okay, I made sure to set target points to the position of the coin before we change the state, and also to connect the signal to the character as opposed to the level itself. Wow, looks like they're going there. I'm just really bad at video games, but it works more or less. Okay, and finally, we're going to implement setting off the alarm. So in order to do this, go to Sentinel, yet again, add new state. We've been through this before. Sounding alarm. This is why I regret not using a match statement here. So if state equals sounding alarm, target lock, target point equals subject dot alarm in range, then the subject will request a path to that alarm. And func exit state subject dot activate alarm, and subject is sounding alarm, and we're going to transition out of it if the sentinel is close enough to the alarm, which we're going to say is like 10 units arbitrarily. Oh, of course, and of course we're going to make them move towards that alarm. A couple things to get this to actually work. We told the state machine to connect to the subject signal of noticing a coin, to activate sound alarm. To make sound alarm work, we made it so that if we increase the distance away from the alarm that they have to be for it to actually successfully make it sound, and we also made it so that instead of shooting, if they're close enough to an alarm, they'll try to sound it. If we test it out, hey, what do you know? Cause those guys to appear. Isn't that neat? And killed me too. Wow, that's interesting. So that's pretty much it. Can't think of anything else to implement for now. Thanks.